Hello and welcome to Saurabh Sir's classes. Today we'll talk about Venn diagram problems. And these kind of problems are very common in competitive exams like CAT, SNAP, GMAT, IFT, XAT and many other exams. Now the question is, how do we identify a problem to be solved by Venn diagrams? Now Venn diagram is a diagrammatic representation of sets. We all know that. So therefore, the simplest rule is that if you encounter a problem involving two or more sets, let's say you are told that there are some coffee drinkers, let's say 70 coffee drinkers, and there are some tea drinkers, let's say 80 tea drinkers, and there are a total of 100 people. Now, you can clearly see here that there are two sets of data given and there is a universal set. So therefore, this will be a Venn diagram problem like this. Similarly, if you are told that there is a class where there are students and some students study physics, some study chemistry, some study mathematics, and there are a total number of, let's say, 200 students. So this is a universal set. Physics is one set, chemistry is another set, mathematics is another set, and the numbers would be given. Or if you are told that there are two cities and in each city there are some customers and they buy shirts and trousers, and there are some customers who can buy both. Let's say this is one city where you have a set of customers, and similarly there is another city with a similar set of customers. So you have four different sets: city 1, city 2. So these are the kind of problems which often come in these kind of exams, which are required to be solved using Venn diagrams. Now let's take some examples. Let us take an example of a problem that came in 2018 CAT paper. It says that a country had sent out 1600 satellites for different purposes like broadcasting, communication, surveillance, and others. And there are some information given about them. Like it says that a satellite can serve either B, S or S, but will not serve O. So this is one condition. So any satellite that serves any of these three categories will not serve the other category. And then there are a set of other conditions given. Now let's first draw the diagram. So let's say this is 1, this is 2, this is 3, and there are 4 of them. So others has to be an exclusive set because it will not have anything in common with B, C and S. And hence our universal set would cover all of them. So our universal set will cover all of them. So this would be our universal set. Yeah, this is our universal set. So now let's look at the conditions. So let's say this is B, this is C, this is S, and this is O. And the total number of satellites we know is 1600. Now we look at the other conditions. The first one says the number of satellites serving B, C and S are in the ratio of 2:1:1. So let B be equal to 2x, then C is equal to x, and S is equal to x. The next one says the number of satellites serving all three is 100. So all three means this one is 100. Then it says the number of satellites exclusively serving C is the same as the number of satellites exclusively serving S. So exclusively C will be, let's say, Y, and this exclusively serving S would also be Y, and this number is 30% of the number of satellites exclusively serving B. So now we change it a little bit. We make B exclusively serving B as Y. So this would be 30% of Y, and this would also be 30% of Y. Then the number 4 says the number of satellites serving O is the same as the number of satellites serving both C and S but not B. Now both C and S and not B means this one. So if this is Z, then O is also Z. So now we have to find out the rest before we go into the questions. So the first thing to note here is that it is given that C and S have the same value. Now if I look at C, it is made up of this, 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 and this. So these are the components of C. And similarly, S is made up of 0.3y, Z, 100, and this. So we see that 0.3y is common here, Z is common, 100 is common. So the only portion left between C and S is this one. Let's say we call it A. So this will also be equal to A. So this is the first thing that we note. Now we are given two conditions that we have to check. One is B is twice of C and twice of S. Twice of C and twice of S. So this is the first condition that we will check for. So let us write it down here. So B will be equal to Y, which is this one, plus A plus 100 plus A again. Now this is twice of C, which means 0.3y, plus A plus 100 plus Z. So this is the first condition. And what is the second condition? The second condition is the total number of satellites is 1600, that is given. So that means the entire set of B, which means Y plus A plus 100 plus A plus 0.3y, Z and 0.3y. This makes up the total of B, C and S plus Z, which is the number of satellites of O. So all this together will make up 1600. So we write that 0.3y plus Z plus 0.3y plus Z is equal to 1600. So this is my second condition. So I simplify these two now. So let's say I simplify the first one first, which will give me Y minus 2 into 0.3y is Y minus 0.6y, that is 0.4y. And then I have A and A2A, and here I have A multiplied by 2 will cancel out, so A will cancel out. Then I have 100 here, and on the other side I have 100 into 2, which is 200, and I have a Z which will be multiplied by 2. So this is equal to 200 minus 100 plus 2z, which is equal to 100 plus 2z. Now, from here I can simplify this further, dividing both sides by 0.4, which makes it y equal to 5z plus 250. Now, this is my third equation, and from here I can see that both y and z have to be positive or 0. It cannot be negative. Number of satellites cannot be negative. So that means if I say y is greater than equal to 0, then 5z plus 250 is greater than equal to 0, which means z is greater than equal to minus 50. Now, z cannot be minus 50. This is wrong. So what is the minimum value of z? 0. That we have clearly understood. So this cannot be the case. So z minimum is equal to 0, and in that case y minimum becomes 5 into 0 plus 250 is 250. So we can see that z minimum is 0 and y minimum is 250. Now let us look at the second equation. Let us mark this one. Z minimum is 0, y minimum is 250. This is important. Now we take the second equation. From there we can write y and then 0.3y and 0.3y. That means 1.6y. And then we have a plus a 2a plus 2a. And then we have 100. And on the other side we have 1600. So we'll transpose that. And we are left with 2z's. So plus 2z is equal to 1600 minus 100 is 1500. And we also have seen that y is equal to 5z plus 250. So I put that here. So I get 1.6 into 5z plus 250 plus 2a plus 2z is equal to 1500. And from there we can write 1.6 into 5 is 8. 1.6 into 5 is 8 plus 2 10z plus 2a. 250 into 1.6 is 400. So 1500 minus 400 is 1100. So this is my fourth equation. This is my fourth equation. And from here I can see that again both z and a have to be 0 or positive. So the minimum value of z is equal to 0, and when z is 0 here, when z is minimum here, a will be maximum. So a max will be 550. So when z is minimum, a is maximum, and the reverse will also be true. When a is maximum, when a is minimum, z is maximum. So z max will be, when a is 0, this will be 110. So z max is 110 when a is minimum, that is 0. So these are the 4 conditions that we can derive from the given set of numbers, that is Z minimum is 0, Y minimum is 250, Z max is 110, and A max and A min are 0 and 550 respectively. Now notice that when Z is minimum, A is maximum. So there is an inverse relationship here, and when Z is maximum, A is minimum, and here also when Z is minimum, Y is minimum. So therefore we get one condition is Z minimum, meaning Y minimum and A maximum, and the other condition is Z maximum. In that case we get A minimum and Y maximum. So Z max is 110. So Y max will be 250 plus 5 into 110, which is 800. Because 5Z plus 250 is Y. So when Z is 110, which is the maximum value it can take, Y will be 800. So Y max will be 800. So this will be Y max and A min. So this is the condition that we have to understand to solve the set of the questions. And we can note down the values here that we have derived. Z minimum is 0, Y minimum is 250, A maximum is 550, and then we have Z maximum is 110, Y maximum is 800, and A minimum is 0. So these are the two set of boundary conditions that defines the values of A, Y, and Z. So that is all we need to solve the questions. So let us look at the questions. The first one says, what best can be said about the number of satellites serving C? Now if we look at the number of satellites serving C, we can easily find out the range, because they are asking for the range, must be between so and so, cannot be more than so and all. So we can clearly see, let me clear the board a little bit. We can clearly see that the number of satellites that are serving C is 0.3y plus 100 plus A plus Z. And we have seen that the maximum and minimum values of A, Y, and Z will lie between these values. So we only need those values here. So Y minimum is equal to, so Y is 250, A is 550, Z is 0. Y is 250, Z is 550, A is 0. I'm sorry, A is 550, the reverse way. A is 550, Z is 0. This is one set, and the other set is Y 800, A 0, Z 110. Y 800, A 0, and Z 110. So now we put this set of values in C, and we can get the maximum and minimum values. So C will be 0.3y, means if I take the first set 75 plus 100 is 175, plus 550 is 725 plus 0. So this would be 725 if I take this set of values, and if I take the other set, then it will be zero point 0.3 into 800, which is 240, plus 100 is 340, plus 0 plus 110, that is 450. So if I take this set, then the value of C will become 450. So we can clearly see that the value of the value of C will lie between 450 and 725, depending on which set of numbers we choose. So the fourth option, which says must be between 450 and 725, is the correct option. The second question says, what is the minimum possible number of satellites serving B exclusively? Minimum possible satellite serving B is Y. Y is the number of satellites serving B, and Y minimum we found out to be 250. This is the minimum value of Y. So 250 is the correct choice. Next, if at least 100 of the 1600 satellites were serving O, what can be the number of satellites serving S? So at least 100 is serving O means Z is greater than equal to 100, and we know that this is less than equal to 110. Then what can be said about the number of satellites serving S? So S again we can see S is 0.3y plus 100 plus a plus z. 0.3y plus 100 plus a plus z. So the number of satellites serving S is 0.3y plus 100 plus a plus z. Now z is 100, means from this equation we get a is equal to 550 minus 500 is 50. So this becomes 50, and from this equation, if z is 100, y becomes 500 plus 250, 750. So y becomes 750. So therefore 0.3y would be 225 plus 100 plus 150, that would be 475. Now the question is, z is at least 100. So z can be more than 100. So z maximum we have seen is 110. So when z is 110, then a becomes 0 and y becomes 800. And so 800 into 0.3 is 240. We've seen this before, plus 100 plus 110 is equal to 450. So this is the minimum value that we had seen that S can take, and now we are getting 475. So this is the minimum value that, this is the maximum value that S can take if Z is at least 100, because Z can be 110. If Z is 110, then the value of S becomes 450, and if Z is 100, then the value of S is 475. So it will be in between these two values. So therefore, at most 475 is the correct choice. We move to the last question. This says, if the number of satellites serving at least 2 among B, C and S is 1200, which of the following must be false? Now at least 2 means this, this, this and this. So this is 2 or 3. So which means at least 2 is equal to 2a plus z plus 100. Now this is equal to 1200. Now this can only happen this can only happen when the value of a is 550 and the value of z is 0. So a is 550 means this is 1100, z is 0 and this is 100. So this is a condition in which the value of at least 2 will be 1200. So then we see the options. All 1600 satellites serve B, C or S, which is true because Z becomes 0. So there are no satellites serving, this is 0. So no satellites is serving O. So this is true. The second one says the number of satellites serving C cannot be uniquely determined. So number of satellites serving C will be 0.3y plus 100 plus a plus z. Now we can define the value of this one because this is the condition and we know the value of z, y and a, so we can find out this value. So this is also true. Cannot be uniquely determined is false, sorry. It can be determined. So this is the one which is false because we can uniquely determine the value of number of satellites serving C. The number of satellites serving B exclusively is exactly 250. B exclusively means Y. So we know the value of Y, 250, this is true. And the number of satellites serving B is more than 1000. Number of satellites serving B will be Y plus 2A plus 100. And here we have A as 550, so 1100. Y would be 250 and 100. So this is more than 1000. So this is also true. So number 2 is false because we can find out the value of the number of satellites serving C. So this is one question on Venn diagram that came in CAT 2018, and you see how easily you can solve it if you just follow a simple logical process. Let's look at another example. This is a problem which came in 2019 CAT paper. It talks about two proposals in a college and it talks about an upcoming election in the same college where we have two candidates, Sunita and Ragini. So we can understand that there are two proposals and two candidates, therefore four choices or four combinations, and there are some information given about the number of students supporting these some of these combinations, and therefore we understand that this would be a Venn diagram problem. So let us draw the diagrams first. So let these two represent the two candidates, and the proposals will be represented like this, right? So let's say this is Sunita and this is Ragini, and let's say the proposals are represented by the circles A and B and A and B here. So we can see that there are some information given. The first one, the first two, A and B, talks about the two proposals, which is not very relevant. Then it says that a student does not necessarily support either of the two proposals. This means that there could be some students who do not support any of A and B. some students might not support any of A and B. So this is one information. Then it says every student prefers one of the two candidates. That means Sunita and Ragini together will make up the total number of candidates. And obviously, no student will support both. So that is understood. So we go into the next set of clues. The first one says a survey was conducted among the students by picking a sample of 500 students. So the total number of students is 500. Okay. Then the following information was noted from the survey. The first one says 250 students supported proposal A and 250 students supported proposal B. So A is 250 and B is 250. Among the 200 students who preferred Sunita as a student union president, 80% supported proposal A. Okay, so which means that it is told that the number of students supporting Sunita is 200. Therefore, number of students supporting Ragini would be 300 because the total is 500. And they are supporting one or the other. And out of the 200 who's supporting Sunita, 80% supports proposal A. That means A is equal to 160. Now, let us see the other clues. Next it says that among those who preferred Ragini, 30% supported proposal A. So we have seen that Ragini is 300. Let us write it here again. Sunita is 200. So 30% of Ragini supporters support proposal A. That means this is 90. Now then it says 20% of those who supported proposal B preferred Sunita. Now number of people who supports proposal B is 250. 20% of that means 50 candidates, and 50 candidates preferred Sunita. So number of candidates who supports proposal B and Sunita is 50. 40% of those who did not support proposal B preferred Ragini. 250 supports proposal B. Therefore, number of candidates not supporting proposal B is 500 minus 250 is 250. So 40% of this number, which is 100, preferred Ragini. That means the number of candidates falling outside B in Ragini is 100. So which means that there are some which will fall here and some which will fall outside in this region. So we don't know the split. So let us keep that in mind for now, that out of this 100 prefers Ragini. Next it says every student who preferred Sunita and supported B also supports proposal A. That means this 50 who are supporting B as well as Sunita also supports proposal A. That means there are no candidates who is supporting only proposal B and supports Sunita. So that means this will become 50 and this will become 110. So therefore we can see that 110 plus 50 is 160 and this is total is 200. So there are 40 candidates who are not supporting any of the proposals but supporting Sunita. Next we go to the next clue, which says, among those who preferred Ragini, 20% did not support any of the proposals. How many students are supporting Ragini? 300. 20% of that means 60. 60 are not supporting any proposal. So that means there are 60 candidates outside the two proposal circles. So which means that we have a total of 300 minus 60, that means 240 people supports one of the proposals A or B and supports Ragini. So let us assume that the number of people who supports both the proposals and supports Ragini is X. Therefore, this part, which is only A and Ragini, would be 90 minus X, and we know that the total is 240. So 240 minus 90 is 150. So this is 150 who are supporting proposal B exclusively and only proposal B and supporting Ragini. Now we had also noted that 100 students who did not support B supports Sunita, or sorry, Ragini. So which means 60 plus 40, which would fall here, would be number of students who do not support B but supports Ragini. So this would be 40. So therefore X is 50. So we have all the numbers now and we can go in for the questions. So let's look at the first question. The first one says, among the students surveyed who supported proposal A, what percentage preferred Sunita for union president? Now, number of students who supported proposal A is 250, and out of this 250, preferring Sunita is 160. So the answer to this question would be 160 by 250 into 100, because the percentage is required. So 160 by 250 into 100, that is 64%. Next we go to the next one. What percentage of students surveyed who did not support proposal A preferred Ragini as the president? So did not support proposal A means again 250, and out of that supporting Ragini means this 150 plus 60 who is not supporting proposal A but supporting Ragini. So 150 plus 60 means 210 out of 250 into 100. So this is 210 by 250 into 100. So this is 84%. Number 3, what percentage of students surveyed who supported both proposals A and B preferred Sunita? Both, supporting both, we can see is 50 and 50, total 100 supporting both, out of which 50 supports Sunita. So 50 out of 100, 100 students support both proposals. So out of which 50 supports Sunita. So 50 by 100 into 100, that is 50%. Last one is, how many of the students surveyed supported proposal B, did not support proposal A and preferred Ragini as the union president? So supporting proposal B and not A means only B, which is 150 here, who is supporting Ragini as the union president. So this would be 150. So you see how simple it is to solve these kind of problems if you can just work out the numbers logically. So if you have any doubts on specifically Venn diagram problems, please let us know in the comment section and we'll clear all your doubts.